Hello and welcome to Edu Sathi's lecture on series. Now, this is a topic wherein you need infinite practice. Why is this so? Because there is no certain set of logics which you can learn and then solve any question on series. You never know what is going in the examiner's mind while he's making a question. So, the only way to get yourself acquainted with a lot of logics is that you practice a lot of questions. In this video lecture, we'll discuss around 9-10 types of concepts which have been generally asked in the examinations, and you'll be able to solve the majority of questions if you are through with these concepts. So let's begin. So the first thing we do is, what are the types of series? We have an alphabetical series, we have a numeric series, and then we have a alphanumeric series. What is an alphabetic series? A series like this. I have only alphabets in the series B, C, E, G, K, or I can have multiple alphabets also like B, M, C, K, E, F, G, H, anything like this. So basically only alphabets. Example for numeric series, I have only numbers. For example, 2, 5, 9, 19, 37, and then they ask you what is the last term. And here you'll have to find out logics like, for example, using operations like multiplication, division, plus, and minus. For example, in this series here, 5 is 2 into 2 plus 1. 9 is 5 into 2 minus 1. 19 is this 9 into 2 plus 1. 37 is 19 into 2 minus 1. So obviously the next term would be 37 into 2 plus 1. Okay, so the answer here would be 75. We'll discuss all these logics as we proceed. Now what is an alphanumeric series? Here I have alphabets, I have symbols, and I have numbers. So three things together make alphanumeric series. Now here questions would be like, if which of the following is the 12th to the left of the 20th from the left end of the above arrangement. So it looks confusing, but what they're asking is, I choose the 20th element from the left here and then again go 12 elements back. So in a way, if I move 20 towards the right and then 12 towards the left, so it means I can just find out my answer by moving 8 steps towards the right. So what is the 8th step? 1, 2, 3, 4, 5, 6, 7 and 8. So this would be the answer. Let's move ahead. Now, concepts for alphabetical series. The only concept you need to remember here is this principle of idioty. Now, it is very difficult for you to remember numbers corresponding to each of the alphabet in the series. This is nothing but A is the first alphabet, so we represent A by 1. B is the second alphabet, so we represent B by 2. Similarly, C by 3, D by 4, and E by 5. So this idioty principle helps you memorize all the 26 numbers easily. For example, I want to find out what is the number corresponding to U. I know that in idioty T is 20, I have 5, J is plus 5 10, O is plus 5 15, T is plus 5 20, and Y is plus 5 25. I know that U is nearest to T, I have T and then U. So if this is 20, then U is 21. So it makes it easier for you to comprehend the number corresponding to the alphabets. So this is the entire arrangement. A is 1, B is 2. Now the first principle we look here is that the reverse order plus normal order is equal to 27. For example, this Z plus A is equal to 27. Similarly, Y plus B is also equal to 27. Then C plus X is also equal to 27. Now this logic has been used in a lot of questions asked in the previous examinations. So make sure that you have good hold over this. For example, they'll give you a series like J is 10 and 17 is, if you look here, Q. So they'll give you something like JQ. Then the next is K. k is 11 and the complement of k is the letter 16, so k and p, so they give you kp. So what is the logic used here? That the sum of the numbers corresponding to these uh, alphabets here is 27. J plus q is 27, k plus p is 27, and the next letter to j is k. So the next letter here would be what? L, and then the corresponding letter to the letter to m would be L, would be L is 12. So I'll have 12 plus 15 is 27. What is 15? O. So the next is going to be LO. So these kind of questions have been asked a lot in previous year examinations. Likewise, we can code the numbers like this. If y is -1, a is 1 and z is 0, or when we go in a roundabout manner, if z is 26, a is 27, b is 28, this is nothing but z plus 1. Similarly, some logics of these kinds can be used. We'll discuss more on this when we do questions. But this one here, reverse order plus normal order is equal to 27, is very important. I've given you a sample question also here. So let's try out the first question. PSVY, then I have this is equal to this, and then what are the four alphabets that will occur instead of this question marks? So let's write down the alphabets here. I have P, S, V and Y. Now P can either correspond to T here or to Z. Let us assume that it corresponds to T. Then S is V, S is V, V is X and Y is Z. I can easily make out that Y and the next element, so plus 0 is Z. The next, or plus 1 is Z. Now V plus 2 is X. I have W in between and then I have X. Now S to V I have T, U and then V. So this is plus 3. Similarly P to T I will have plus 4. Q, R and S. So what is the logic used here? That the last element Y here is replaced by Z. So similarly P here, the last element for G, J, M and P, the last element here P would be replaced by Q. Just add plus 1. M would be replaced by plus 2 here. So we have N and then we have O. So M is replaced by O. Similarly J to the next element would be plus 3. So I have K, L and here I would have M. Similarly here I'll have plus 4, H, I, J and then I have K. So what is the code for the question marks here? I have K, M, O, Q. Let's check out the options. So this option here is the correct option. So this question was entirely based on replacing the alphabets by numbers and then forming operations on numbers. Replacing alphabets by numbers. Let's try out more questions. In a certain code language, system is coded as this. Then what will be the code for pencil? Now I know that this system has been coded like this. Now I have to find out what does S here correspond to here. Either it corresponds to L or to T. This is a general logic which is used. They can form other logics also, that this SYS has been reversed or something like this. Anything can be there, but generally we try to find correspondence of the first letter here to the first letter here, or the first letter here to the last letter here. So if I take the first and first, it means that S corresponds to L. If I take the second case, then S will correspond to T. Now S and T are relatively closer in the alphabetical series, so Just by intuition, I will go with this logic first and leave this logic for later. So S has been replaced by T. I am assuming this. Then let's look at the second letter here. This is Y. Now Y then will be replaced by X. So Y corresponds to X. Now this is plus 1 and this is minus 1 because X plus 1 is Y or Y minus 1 is X. Let's look at the third letter here. This is S again and I have a T again. So again S plus 1 and I have T. Similarly, I have T here and this T corresponds to S here. So T corresponds to S. So this is again minus 1. E corresponds to F. So E is corresponding to F. So E plus 1 is F. And then finally M minus 1 is L. So I can find a good logic here. Plus 1, minus 1, plus 1, minus 1, plus 1 and minus 1. So similarly, I will do it for pencil. I have P, E, N, C, I, L. Now for this L, I will do a minus 1 as here. So this gives me K. For this I, I'll do a plus 1. So this is J. For C, I'll do a minus 1. So this gives me B. For N, I'll do a plus 1. This gives me O. A minus 1 gives me D. And a plus 1 gives me Q. And what is the code? I'll start from the reverse because here also we started from the reverse. L, F, S, T, X, T as it's mentioned here. So what is the code here? I have K, J, B, O, D and Q. Let's check out the options. So K, this one is wrong. K, J, B, O, D, Q. So this A part is the correct answer option here. Now it is equally likely that when system is coded as, let's say this one only, L, F, S, T, X, T, this S corresponds to this T and this Y corresponds to this L, and then again this S corresponds to this X and this T corresponds to this F. The only point is that you need to find a logic. Here I was able to find out the logic in the first go, so this made my life easier. This is also an equally likely possible case, but then you need to find logic, that what is the logic behind this. That is why I say that you need to have a lot of practice in these questions. Let's try out the third question. I have A1, E5, I9 and O15. One thing I'm sure of is that A is the first letter in the alphabetical series, that is why I have A1. E is the fifth letter, that is why E5. I is the ninth letter, that is why I9. And O is the 15th letter, therefore O15. So I definitely know that I just need to find out the alphabet which will lie here and then its corresponding number. So I look at the alphabets only. I have A, E, I and O. These are all vowels. The only vowel left out is U and its place is 21 in the series. So U21 is the answer. Now let's look at this question. In a particular code language, the alphabets are written as A is equal to 3, B is equal to 6, C is equal to 11, D is equal to 18 and E is equal to 27 and so on. What will be the code for the word open? So I have formed a table here. So if A is 3 and B is 6, so I have a plus 3 here. Then if I go to C, I have a plus 5. 6 plus 5 is 11. If I go from C to D, I have a plus 7. From D to E, I have a plus 9. Now this is enough for me to find a logic that I am just adding the odd numbers in the ascending order. So the next F would be plus 11, G would be plus 13, H would be plus 15, 51 plus 15 is 66. Similarly, plus 17, plus 19 and so on. So this will take you a lot of time and then you'll finally be able to find out that O is 227, P is 258 and n is 198. So what is the right answer option here? This one, 227, 258, 27 and 198. But you don't have so much of time in the examination to do all these calculations. So let's look at this question by logic. I'll just change the ink color. I'll use the blue for the next approach. I know that the numbers are increasing. Obviously b is greater than a, c would be greater than b, and e would be greater than all these alphabets coming before e. I know that in this word open, e will definitely be 27. So that is true in all the cases. This does not help me. The second thing I know is that O occurs before P in the alphabetical series. So the number for O has to be this is the representation for the number for O, has to be less than the number for P. Now I look at the answer options here. The number for O is less than the number of P. This is okay. Here the number of O is 291 and the number of P is 227. This cannot be the answer. Similarly here I have 258 and 198. This also cannot be the answer because the number for P has to be greater than the number of O. So just by looking at the answer options, I am just left with two options, the first one and the last one. Now the first three numbers are same in both of them. So the only difference is for n. Here n is coded as 171 and here n is coded as 198. Now I know from this Ijotti principle that O is the 15th letter in the series and n is just before O, so the n is the 14th letter in the series, and I am just adding odd numbers. This logic I've already figured out. So what would be n? N would be A plus the sum of first 14 odd natural numbers. So odd natural numbers, odd nn minus 1. Because I have not added 1, I have started with plus 3. So this gives me this, the number for A is 3 plus what is the formula for the sum of first n odd natural numbers? It is nothing but n square minus 1, where n is the number of terms. For example, if I have just two odd numbers 1 and 3, these are the first two odd numbers. So their sum is 4, which is also equal to n square. Since I took only two numbers, so 2 square is 4. If you take 3, so let's say 1, 3 and 5, then their sum is 9, which is nothing but 3 square, as I took the first 3 odd natural numbers. You will have more clarity on this when you go through the PPT on algebra. So this n square has to be odd numbers and the first n odd numbers. So this gives me 3 plus what is 14 square minus 1. So I'll just continue here. This gives me 3 plus 196 minus 1 or 198. So answer D is the option and this is incorrect. So just by finding out what is the code for n, I was easily able to solve this question in just 1 minute. But I have done minus 1 here because I have started from 3. This series starts from 3, but this formula n square counts the series from the first odd natural number, which is 1. That is why I did this minus 1 here. Let's try out this another question. I have a series and then I have a couple of, more than a couple of blanks here. We have to fill these blanks. I know that the answer options has only A, B, C, D and F. So something till F only has to figure out in these blanks. I know that A is the first letter in the series, so that is why A will occur only once. Then B is the second letter, so let's say B occur twice. C is the third letter, so let's say 3 will occur 3 times. D will occur 4 times and E occurs 5 times. So I just started off with the logic. This logic might have gone wrong when I'm solving the question, but here it fits me very well. So what is my answer? B, C D, D and triple E. So this one B, C, double D and triple E is the answer option. So if you get the answer easily on series, it's very good, but don't spend more than 3 minutes on solving a question, because if you couldn't figure out in the first 3 minutes, you will never figure out in the examination. So don't waste time and move on to the next question. So basically, in alphabetical series, you'll only correspond to the numbers and then find out the answer. Let's try another question. Which term comes next in the sequence AC, FH, KM, PR, and then we have a dash. So I know that AC, I've missed out B here. Then in the second term, I miss out D and E and I start from F. F and H, I miss out a G here. After H, I miss out on I and J, and then I have K, I miss out L, and then I have M. Similarly, after M, I miss out N and O. I have P, I miss out Q and R. So now it's pretty simple. The next one would be after R, I'll miss out S and T. So that is why I have a U. I'll miss out a V and then I'll write W. So this first option here, the A part, is the right answer. We now move on to the second type of series, which is a numeric series. So the first concept for numeric series is that the series can be in arithmetic progression. This is also called AP. Now what does AP mean? That the common difference or the difference between the consecutive terms would be the same. So for example, I have 3 plus 3 is equal to 6, 6 plus 3 is equal to 9, 9 plus 3 is equal to 12, 12 plus 3 is equal to 15, and 15 plus 3, 18 would be the next term. So the terms are something like if the first term is labeled as A, this is 3 here, and the second term is A plus D, D is what here? D is also 3, which is the difference which is common between any two consecutive terms. That is why we mention this D as the common difference, because it is common, it is same across all consecutive terms. So this second term is 3 plus 3, which is 6. This third term would be A, the first term, plus 2 into 3, this gives me 9, and so on. So for the third term, I am adding the common difference twice. This is the third term. Similarly, for the fourth term, I am multiplying the common difference by 3 and then adding. So if the first term is A and the common difference is given by D, then the general term or the nth term is given as A plus n minus 1 into D. Why is this n minus 1? Because as we seen here, that in the fourth term I add 3 times D. In the third term I add 2 times D. In this second term I just add 1 time D. So this is 2 minus 1 1. This is 3 minus 1 2. This is 4 minus 1 3. Therefore for the nth term n minus 1 multiplied by D. Let's look at a couple of questions on this. 357, 363, 369. What will be the 10th term? So I have A here as 357. What is D? D is 363 minus 357. So this gives me 6. Also I'll check for the third and the second term. This is 369 minus 363, and this gives me again as 6. So common difference D is 6. I need to find out the 10th term. So A plus 10 minus 1 multiplied by D, or this gives me A plus 9 times D. A is what? 357. 9 multiplied by 6. Sorry, this is not 354, this is 357. Then I have 357 plus 54. This gives me 411 as the 10th term. So this is my correct option. answer option here. This topic of arithmetic progressions, geometric progressions, which we'll do later in this video presentation as well, has also been covered in algebra in the quantitative ability section, but in more detail. Here I'm doing the formulas only which are important from this series point of view. Let's try another question. I have 201, 208, 215 and 369. We have to find out the number of term in the series. So I know this is the last term. So let's say this is the nth term. So 369 is equal to A plus n minus 1 into D. I have to find out this n. What is A here? 201. So I have 369 is equal to 201 plus n minus 1 multiplied by D. What is D? I have 7. 208 minus 201. Similarly, 215 minus 208 is also 7. So D is 7. So I multiply this by 7. Now just solving this equation, I have 168 is equal to n minus 1 multiplied by 7. This gives me 24 is equal to n minus 1. So 25 is equal to n. So the number of terms in the series is 25. Find the 16th term of the series. Now here also A is 369. Let's find out what is D. So D is 362 minus 369 or minus 7. Also D is equal to 355 minus 362. This is equal to minus 7. So common difference can also be negative. This is the only purpose of this question. I want to find out the 16th term. So the 16th term would be A plus 16 minus 1 into D. What is A? A is 369 plus 15 multiplied by minus 7 here. So this gives me 369 minus 105 or 264. So this B part here is my option. So arithmetic series can be an increasing series in which D is positive. So this is an increasing series. If D is negative, then it is a decreasing series. Let's move on to the second concept, which is geometric progression, or this is also called as GP. Again, GP has also been discussed in the topic called algebra in the quantitative ability section. There GP would be discussed in more detail, like for example what is the formula for sum of series and more things, but here we are only concerned with the general term from the perspective of series. So what is GP? I have 1, then I have 4. So 4 can be written as 1 into 4. Similarly 16 is 4 multiplied by 4. 64 is 16 multiplied by 4. And 256 is 64 multiplied by 4. So what I'm doing here is I'm multiplying by 4 the previous term. So I had 1. So this previous term 1 into 4 is the second term. Similarly, the third term is this previous term 4 again multiplied by 4. How did 64 come up? This previous term 16 multiplied by 4. How did 256 come up? 64, which is the previous term, multiplied by 4. So in AP, I was adding or subtracting some common number which was mentioned as D. In GP, I would be multiplying or dividing by a common number which is known as R, and this is known as a common ratio. This common ratio denoted by R. Here this was the common difference. So what are the terms here? I have the first term as A, this is 1. What is the second term? A multiplied by R. R is 4 here. So 1 into 4. What is the third term? I have A, which is 1 multiplied by R square. So A into 4 into 4. This gives me 16 here. Similarly, the fourth term, 1 multiplied by 4 raised to power 3. So again, if you notice here, if I have the fourth term, I have 3 in the power. If I have the third term, I have 2 in the power. If I have the second term, I just have 1 in the power. So for the formula for the general nth term would be a multiplied by r raised to power n minus 1. This is the nth term. This is similar to what we did in the previous slides, which was for AP. There also we had n minus 1. Here also we have n minus 1. Let's do a few questions on this. In the series 7, 14, 28, 56, what is the 10th term? So I need to find out the 10th term. That would be a r raised to power n minus 1. N is 10 here. So this gives me a r raised to power 10 minus 1. Or this gives me a r raised to power 9. Now what is r? There we subtracted in AP, we subtracted the first term from the second term. Here we will divide. So common ratio r is given as 14 divided by 7. This is also equal to 28 divided by 14, also equal to 56 divided by 28. So what you do is you take consecutive terms. This is the second term, this is the first term, this is the third term, this is the second term. So you take consecutive terms and then you find out this common ratio, and always it would be the second term over the first term, the third term over the second term, not the opposite. So the higher number term will always be in the numerator and the smaller number term will always be in the denominator. Smaller number as in according to the number basis which they occur in this series. So I know that r is 2. So this gives me 7 multiplied by 2 raised to power 9. Now we all know that 2 raised to power 9 is 512. So what is my answer? 3584. This is the 10th term of this series. Let's move on to the next question. Find the number of terms in the series, and this is a series. So let's find out r first. R would be 6 by 2, or it would be 18 by 6. These both are same, and r is 3. Now 1458 is equal to a r raised to power n minus 1. So 1458, what is a? A is the first term, which is 2. So this gives me 2, and r is how much? 3 raised to power n minus 1. So if I cancel out 2, then I get 729 is equal to 3 raised to power n minus 1. I know that 3 raised to power 6 is 729. So 3 raised to power 6 is equal to 3 raised to power n minus 1. So n minus 1 is equal to 6, or in other words, n is equal to 7. What is the correct option here? 7. Now let's move on to the third concept for numeric series. The series can be squares or cubes of natural numbers. For example, squares are 1, 4, 9, 16, 25. They can stop the series here and ask you what is the next term. So this is 1 square, this is 2 square, this is 3 square, this is 4 square, this is 5 square, and this, the next term would definitely be 6 square. Similarly, the same thing can be done for cubes. These are very easy, and you should definitely have a good hold on them. Or they can do is, what they can do, they can ask 1, 9, 25, 49, and what is the next term. So I know that this is 1 square, this is 3 square, this is 5 square, this is 7 square. So the series is just the square of the odd natural numbers. So the next term would be definitely 9 square, which is 81. So remember, it is advised to memorize the squares of first 30 natural numbers and cubes of first 15 natural numbers. Now a series, the fourth concept here, can also be a combination of what we've discussed before: plus, minus, multiply, divide. This is AP, this is GP, and then we have cubes and squares. So any combination of these. How do we solve them? We use what is known as a pyramid pattern. What are the conditions for this pyramid pattern to be applied? The series is either continuously increasing or continuously decreasing. The series has a general term. There are no fluctuations. For example, it cannot be like I'm increasing the series at 1, let's say 2, 7, 8, 9, and then suddenly it becomes 0. So these fluctuations are not allowed. So increasing and decreasing both are not allowed. No repetition of terms except the first two terms. For example, the series cannot be like 2, 7, 8, 9, 9, and then 18. So this is a repetition. This should not be there. But the first two terms can be repeated. For example, 1, 1, and then 2, and then 3, 4. If a series is like this, then pyramid rule can be applied, but not like this. So the repetition should not be in the middle somewhere. Let's practice questions and learn how to apply this pyramid pattern. Let's look at this first question on numeric series. This is the one which we already discussed in the first slide. So I'll just repeat this 5. The second term is nothing but the first term, which is 2 multiplied by 2 plus 1. This third term here is the second term, 5 into 2 minus 1. This fourth term is 9 into 2 plus 1. This fifth term here is 19 into 2 minus 1. So this term here would be 37 into 2 plus 1, and this is 75. So this was an relatively easy question. Just a combination of multiplication, minus, and multiplication, subtraction, and addition. Let's move on to the next question. Find the next term of the series 0, 4, 18, 48, and 100. Now here, even if you pause this video and think for a while, you'll not be able to apply a combination of multiplication, minus, division, and plus. Division cannot be applied because it's an increasing. So the remaining operations, multiplication, subtraction, and addition, if you try and figure out, you'll not be able to find out any logic. This is where pyramid series come handy. What is pyramid? I will just write down the series here, and we'll make a pyramid out of it. And here I have question mark. How do you make a pyramid? You'll take first two terms and subtract the first term from the second term. So this gives me 4. Similarly, you do it for the next two terms. 18 minus 4 is 14. Then 48 minus 18 is 30, and 100 minus 48 is 52. This is the first stage of the pyramid. Now you look at this stage and find out if you can find any logic between 4, 14, 32, and 52. So I can do 4 into 3, 12 plus 2, but 14 into 3 is too much. So again, if you pause this video here and try to find out a logic at this stage here, you'll not be able to find out a logic using these three signs. So what you do is you move on to the next layer of pyramid. Then you take the difference between the first and second term at this stage. So this gives me 10. The difference between both of them is 16, and the difference here is 22. So now I have an easy logic that 10 plus 6 is 16, and 16 plus 6 is 22. I have a logic at this stage of pyramid, so I'll stop here. Now we'll start moving from this bottom of the pyramid towards the top, and then find out the value of the question marks here. So what I'll do here is, in 22 I'll add 6, so 28 will figure out here. If 28 figures out here, I'll draw a reverse line. It means that 28 plus 52, which is 80, was here. That is why 80 minus 52 gave me 28 here. Now again, if 80 is here, then this figure x here and this 100 here, when I subtracted 100 from x, so x minus 100 is 80, as we did in the previous case. So this number here is 180. What is the correct answer here? 180. If you are finding it difficult, This 52 was what? 100 minus 48. This 30 was what? 48 minus 18. Similarly, this 80 would be what? This x minus 100. So if 80 is equal to x minus 100, then x is 180. Let's try this next question. I have 4, 8, 28, 80, 244. Now if you remember cubes and squares, you'll be able to find out the answer to this question in just a second. So what is 4? 4 is 3 plus 1. What is 8? 8 is 3 square minus 1. What is 28? It is 3 raised to power 3 plus 1. What is 80? 3 raised to power 4 minus 1, because 3 raised to power 4 is what? 81. Similarly 244, this is 3 raised to power 5 plus 1. So here I'll have 3 raised to power 6 minus 1, which is 729 minus 1, or 728. So this is my right option here. How was I able to figure out? Because I could see that I have a 27 here, 81 I know is a multiple of 3, and then here 9. So by intuitiveness I was able to find out the answer to this question. When you also practice a lot, you will also get these intuitions. Find the next term to the series 3, 15, 35, 63, 99. So 3 is nothing but 1 into 3. 15 is 3 into 5. 35 is 5 into 7. 63 is 7 into 9. 99 is 9 into 11. So by logic the next term would be 11 into 13, which is 143. I'm just multiplying the odd numbers and then I figured out this answer. So this was simple. Find the next term of the series 1, 4, 13, 20, 121. Now just by looking at it, I cannot figure out squares or cubes or a combination of plus, minus and multiplication. So what I do is I'll apply the pyramid pattern. This pyramid pattern will more often than not always work. So I have 1, 4, 13, 40 and 121, and then I have to find out this x. So 1 and 4 gives me 3, this gives me 9, this gives me 27, this gives me 81. So at stage 1 only I have the logic. This is 3, this is 3 square, this is 3 cube, this is 3 raised to power 4. So the next term is going to be 3 raised to power 5, which is 243, and x minus 243 is equal to 121. So x is nothing but 364. So this is the correct option. Now we'll move on to the next concept, which is a combination of 2 or more patterns. Whenever you have a fluctuating series, now what do you mean by fluctuating? See, I have 4, 7, 10, 11, 22, 17. This is a fluctuation. There's a decrease. Then I have 46 and then 25. Again, there's a decrease. So whenever you have such kind of fluctuating series, it should always strike you that this series is not made up of 1 but 2 series. These are very important type of questions and very frequently asked. So how do I break down? The first series could be 4, then 10. So this 4 plus 6 is 10. 10 plus 12 is 22. 22 plus 24 is 46. And then I'll have this number here. So this number is getting multiplied by 2 and then being added to the previous number in this series. Let's look at the second series, which is here. I have 7. 7 plus, sorry, I'll not have 10 here because this is the just next number to 7, I will have this 11 here. So I'll sorry for this. So 7 plus 4 is 11. Then I'll skip this 22. 11 plus 6 is 17, and 17 plus 8 is 25. So what the question would be, that answer the next two numbers in this series. So the second number will come through this series in blue. So I have added 8. 25 plus 10, the next number here would be 35. As I'm adding 4, 6, 8, and then this would be plus 10. Similarly, the first series, I changed the color to red again, would be 6, 12, 24. The next number to be added here would be plus 48, which is double of 24. So 46 plus 48 would give me 94. So what are the next two numbers? 94 and 35. So they are made up of two series and not one. One of the series is in red and the other series is in blue. Similarly, whenever you have repetition of terms, it would be definitely two series and not one. So let's look here. See, I have 36 and 36, a repetition coming here. Again, what I'll do is I have this 4. 4 changes to 12. This 12 changes to 36. This 36 changes to 108. And this 108 will change to something here after a term. So 4 into 3 is 12. 12 into 3 is 36. So this is multiplied by 3. This is multiplied by 3. This is multiplied by 3. This is a GP. So 108 would be multiplied by 3. So this will give you 324. Let's look at the second series here. I have 4. Then I have 16. Then I have 36. Now 4 is what? 2 square. 16 is what? 4 square. 36 is what? 6 square. So here I'll have 8 square or 64. This is 8 square. So 64 and 324 are the next two terms in this series. So make sure then whenever you have a fluctuating series or a repetition of terms, definitely the question is made up of not one but two series. A series of prime numbers could be like 2, 3, 5, 7, 11, 13, 9, 17, 19, 23, 29. So if you find out by pyramid rule or any rule which you apply, you will not be able to find out. The next term will definitely be 31, which is the next prime number. If you look here, this is 2 square, this is 3 square, this is 5 square, 7 square, 11 square, 13 square. So the series is a square of the prime numbers. Again, a different type of series. So the next term is definitely going to be 17 square or 343. So let's look at the next concept here. This concept is on composite number series. So what would be the next term in the series given below? 1, 2 and 3. 1 is neither prime nor composite. 2 is a prime number. 3 is a prime number. That is why the series starts with 4. Then 5 is a prime number. 6. 7 is a prime number. Then 8. 9 is a composite number. 10 is a composite number. 11 is a prime number which is left out. 12 is a composite number. Then 13 would not occur because it's a prime number again. So the answer here is 14. Similarly, this series here is nothing but the square of the series mentioned above. 16 is 4 square, 36 is 6 square, this is 8 square, 9 square, 10 square, 12 square. So here I'll have 14 square, which is 196. Just another concept for you to keep in mind. Let's move on to the next concept, which is factorial series. Factorial has been explained in detail in the video of permutations and combinations, but I'll just give you a brief here of what a factorial is. Let's say I have to find out 5 factorial. So what I'll do is I'll start from 5 and I'll end at 1. So 5 multiplied by 4 multiplied by 3, multiplied by 2, and multiplied by 1. Similarly, if I have to find out 3 factorial, I'll start with 3, then 2, and then 1. This is what is a factorial. You start from the number and end at 1. This is 120 and this is 6. Applications of factorial are in PNC. So, and another thing you have to notice that 0 factorial is equal to 1. Find the next term in the series given below. So I have 0 factorial as 1, 1 factorial again is 1, 2 factorial would be 2 into 1, which is 2, 3 factorial as I've mentioned here is 6, this is 4 factorial, this is 5 factorial, this is 6 factorial. So the next term would be 7 factorial, which is nothing but 5040. This can be written as 5 factorial, which we already know, 120 multiplied by 6 multiplied by 7. This will give you 5040. Now let's move on to the miscellaneous examples. Find the next term in the series given below. In this series, if you apply the pyramid form or a combination of these or any logic, it can take you days and you will not be able to find out the answer. This is the type of miscellaneous examples that are generally asked. So how to solve this kind? I take the first number here, this is 9, then I have 16, I have 25, I have 36. So 9 is 3 square, 4 square, 5 square, 6 square. So the first two numbers here would be 49, which is 7 square. Now I look at the second half. I have 4, 6, 8 and 10. So the next thing would be 12. What is my answer here? 4912. That is why, if you remember, in the starting of the video lecture I told you that they are infinite logics, and all you can do to excel in this topic is practice. We have another miscellaneous example. Find the next term in the series given below. I have 34, 81, 72, 47, 74, 27 and 18. This is a fluctuating series. So definitely I cannot apply the pyramid rule or a combination of plus, multiply, divide and subtraction. There has to be some other logic. So if you look carefully, I have 81 here and the reverse of 81, 18 here. 72 here, reverse of 72, 27 here. 47 here, reverse of 47, 74 here. So what is the next term? Here I'll have reverse of 34, which is 43. So this is my answer. When you get into calculations like these, it can take you days to solve this question. So my advice is, give 2-3 minutes to a question. If you're not able to figure out, leave that question and move on to the next one. Now we move to the last type of series, which is alphanumeric series. Now alphanumeric series is a random collection of letters, numbers and symbols. All you need to know for alphanumeric series are that you have vowels, which are A, E, I, O and U. Consonants, all letters except vowels. Numbers are like 1, 2, 3 and 4. And symbols are like this exclamation mark, @ sign, a hashtag, dollar, percentage, etc. This is the only literature you need to know for alphanumeric series. We'll look at a few questions. So what are the directions? Study the following arrangement carefully and answer the questions given below. So this is the arrangement. Let's read the question first. How many such numbers are there? Numbers in the above arrangement, each of which is immediately preceded by a consonant and also immediately followed by a symbol. So I need to have a consonant and then a symbol. So what we'll do is we'll list down the numbers first. I have 5 here. This is preceded by a consonant but not followed by a symbol. So this is not in my set. This 8 is preceded by a number. This goes wrong here. I have 4. F is a consonant but J is not a symbol. So this is also not true. I have 1. J is a consonant here, but it is not followed by a symbol, so this is also not true. I have 2, H is a consonant, and this C is a symbol. So this is the first number which lies in my set. I have a 9 here, not preceded by a consonant, so this is wrong. I have 6 preceded by a consonant followed by a symbol, so this is again in my target set. 3 again not, because not followed by a symbol. 7 again in my set because it is preceded by a consonant and followed by a symbol. So what is my answer here? I have 3 numbers in my set, 1, 2 and 3. So this is the right option. Only concentration and focus is required to answer these questions. Let's try another one. How many such symbols are there in the above arrangement, each of which is immediately preceded by a letter? So I need symbols preceded by a letter and also immediately followed by a number. So I want a symbol preceded by a letter L and followed by a number N. So let's take this first symbol. It is preceded by a letter but not followed by a number, so not in my set. Second symbol, preceded by a letter not followed by a number, again not in my set. The third symbol, again preceded by a letter but not followed by a number, not in my set. This is not preceded by a number, again not in the set. Not preceded by a number, not in my set. Preceded by a letter but not followed by a number, and this is also not true because it's not preceded by a letter, it is preceded by a number and followed by a letter, the reverse of what we are looking for. So the correct option here is none of the above. How many consonants are there in the above arrangement, each of which is immediately preceded by a consonant and also immediately followed by a number? So I have the first consonant here, it is not preceded by anything, so this is not in my set. I'll just change the ink color for this question. So this B is not in my set, this is not a consonant. Now R is a consonant but it is not preceded by a consonant, it is preceded by a vowel which is A, so this is also again not in my set. E again not in the set because it is not preceded by a consonant. M again not in the set as it is preceded by a symbol. I have F here, this is preceded by a consonant and followed by a number, so the first correct option here is this. Then U is not a consonant. J again not in the set, it is not preceded by a consonant. H again not because it's preceded by a symbol. T again preceded by a number. I is a vowel. W again preceded by a symbol and not by a consonant. P also not in the set because it's preceded by 3. K again not in the set, preceded by a number, and then I have Y which is again preceded by a symbol. So there is just one consonant which is preceded by a consonant and followed by a number. That is all on series. I hope you enjoyed this lecture and do practice a lot. Thank you.